now. Yeah, so it is nice having you guys once again. Um, Basic introduction. My name is Kyle Diademi. So in today's video, we'll go into how to set up a development cluster, which is Minikube. Then we'll actually provision resources on the cluster. So we'll provision Kubernetes deployment, also replica sets. Then also we'll dive into excuse me. So let me know if you can see my screen. You can just do a thumb up. Then also added ingress. So I'll explain how to use this ingress. Okay, thank you, Binga. Then the secret. So this is the manifest script, whereby we'll dive into everything. But before we go this, like I said, personally, or prerequisite before you start going to Docker, it is advisable to have some basics about Docker container, or have some understanding about the networking, then also how to actually troubleshoot the basics. Because the truth about it is, if you have some knowledge about Docker, it's make it easy for you to adapt with Kubernetes. However, I know most of us here are interested in Kubernetes, but I'm just trying to give this as an hands up and as a guide. And Docker is not as complicated or as complex as Kubernetes, right? So let's just go into this. So there are two ways which you can actually uh, create your container. You can use Docker Compose. Then you can also well, Docker Compose is more like a declarative way of actually creating your container and running it on, what is it called? On the CLI command. That is imperative way of actually provision your node container. So this is a sample. This is a sample script for creating Docker container, and this is also what do we have here? We have our service. We have our service, our network. So most cases, I always try to create my network. So this is a script of creating your Docker network. So these are just placeholder where you can easily override it. So a simple way is something like this. Node Node.js. Let's give it a good sample. Let's see Unity network. So once you have something like this, it's easy for you to to create a network. So or what for me personally, so this is more like a template. So if I just do this, so what I have here is that it helps me to override all those default, all those placeholder which I have here. So if I run this script now, it will create a network, a Docker network of Unity net. So I have this here. So once I copy this, then I go to my deploy image, where I have network here. This. So just replace it with this. Then I think that is all on the. So I just create a script. This script, this is all what I have to run on my terminal for me to bring up a node container. So in order for me to, so the benefit of script is it helps you to automate the process. Then also it reduce trial and error, and also it makes your another benefit, right? So it also makes troubleshooting very easy, then also make it very it helps you to reduce try, which is called don't repeat yourself. So you just run it once and everything is up and running. So in my case here, I've I also have a, because by default you can't roll back on no on Docker. So I have a script that helps me to have a backup image, right? I have a script that helps me to have a backup image. Um, so that is what this does. So it helps me roll back, create a backup image. So in case the first image container is corrupted, so I can use the backup and bring up my Docker container. Then I've updated this. So this is Docker post. So here that I have network name. So I can easily update this. So that is done. Um, then this is my service. I replace this with the image, which if I have, then um, this is my edge check. So we won't go in depth into this. So I just created this for the purpose of those that want to get familiar with uh, Docker Compose, right? So that is fine on that. So let's try this. So what I want to do, I want to run everything in the script. So the first thing first is to create a Docker network. So I've created the network, right? So network unity net created successfully. So the next thing is to bring up my node. Yes, my Node.js one. So my Node.js will be running in a Docker container connected to this network. So you can also have other container running on the same network. So it means that each container can communicate to the same network, and they are actually isolated in in that network. So for any network that want to connect with it, they have to connect to it through the gateway. So yeah, so this is pulling my image because the image is posted in a private or GitHub container registry. So I added my secret. Is really my secret here. So you log into Docker, you log into GCR, which is GitHub container registry. Put the image. If it's a public image, you don't have to log in. So you just I added this for the benefit of those that always have their image posted in a private container registry. Yeah, so that is all I have to do to bring up this container. So some common command you do is docker network list. So the one we created now is unity net, right? So let's inspect unity net. So in this unity net, I believe we have only one container. So this is the only container that is running on this network. So for any network that wants to connect to this container, so they will use the container name. So the DNS helps resolve the container name to this IP address so that they can communicate to one another. So Docker PS. So this is the only container that I'm running currently. So this is the image. This is the container name, and I'm running on 3001. So this is our edge check. So if I do crawl HTTP localhost, so we are on localhost, then on that port 3001/x. So welcome to Node.js Expert, right? So I can do this so that you can see it properly. Okay. Oh, it's not returning a. Oh, this is a text, not a JSON. Okay, that is fine. So this is what we expect. Welcome to Node.js. So it means the service is up and run. So now that we have this running on a Node container, or we can also have this running on a Kubernetes cluster. Yeah, I'm coming. Oh, someone is trying to join. I think someone is trying to join. Okay, yeah, we have a new visitor. So that is all on the Node, on the um Docker part of it. So if you have any question, just drop your question in the chat. I will address that. So apologies um for the issue I had in our last session. I lost the video recording. So thank you for joining for today's session. So now let's go into Kubernetes. Um, so I have this on GitHub. So after this session, I'll push this chain to GitHub. You can always access it, and also you can drop your comments or you raise a PR. Then we can take it up from there. Okay, now we are on Kubernetes registry. So I zipped this manifest file because I was trying to run this cluster on ECA or EC2 instance. Um, so will EC2 stand as, or is a service on AWS that helps you to have more like your system and environment on a cloud service where you can host your web app. You can also provision a Kubernetes cluster and run your manifest script in that cluster as much as possible. However, um, AWS have a service called Elastic Kubernetes Service, which is EKS. So it's an Elastic Kubernetes cluster that helps you to manage most of all these resources behind the scene. However, you can also make some custom change, and the benefit of EKS is that you don't have to manually um, provision most of all the resources to set up a full Kubernetes cluster, and auto scaling, whereby you can actually provision the number of node that you want to run behind the scene. So um, for this, we'll be having a single node that also serve as our control plane or a master node. So I have Minikube running on my installed. I don't think it's run currently. I might be wrong, but let me check. So this is the status. Okay, it's not running. Yeah, I think I'm right. So I'll start it with this code. So Minikube actually use Docker. It's run on a Docker container. So use Docker. Okay, yeah. It will start in existing Docker container. So it's create it's run VM. And some, if you are working with networking, maybe for instance now you want to integrate provision ingress, and you are trying to map with a host like a DNS, you might actually come across some issue that have to do with NAT. Um, it make it very difficult for you to map your domain with the address. But normally, if you can provision these resources, just probably be the hard way, which they call, or setting up different resources, then you can easily um, connect to a service using node ports and the port. So we'll go over that. And so now my cluster is up and running. So let me do Kubernetes. Oh, it's not Kubernetes, Minikube status. So I believe we see our control plane. Okay, yeah. So type of control plane host is running. So kubelet, kubeconfig, these are set up. So meaning I can run my kubectl, I can run all those commands here. So now I have this. So I created a readme file. So this readme file serve as a guide on how to troubleshoot and how to provision all these resources. So let's open that. Okay, so this is what I have, the Node.js Express Kubernetes deployment. So there's difference between deployment and replica set. So replica set or deployment manage replica set. So replica set helps you to manage the number of nodes you can have, maybe 1, 2, 3, depending on the number of pod. I mean, not node. Apology for that. So a replica set helps you to manage the number of pod you can have. Then deployment manage replica set. So on your replica in your node, you set up your pod and other resources management. So let's go to a sample deployment. Hold on, we have a guest. Okay. Oh, a quick one, guys. Please thumb up if I'm audible. Okay, thank you. Yeah. So um, this is our manifest file, which is a deployment manifest file. Um, uh, uh, so I have to zoom in the screen. Then you see my VS Code terminal. So this is how you create a deployment manifest file. So I what I have here is I want to run 3 pod, then my deployment strategy or rolling update. So um, maximum unavailable, which is 0, then maximum search 1. So selector match. So this helps you to label your pod, helps you to manage your resources, your deployment. So and also the benefit of this is probably you create a secret, and that secret you want to actually uh, resolve it maybe in your pod or your deployment. So you can use your selector and your label, or maybe you create a service. This helps you to do that. So now this is our template where everything resides. So you can also see we have our labels here. You can have as many label. This is map. You can add your key value, anything key value as much as you like. So the benefit of this is probably maybe you want to troubleshoot or you want to log. So you can just put this label and pass in any of this value. Yeah. So that is the benefit of label. So now in most tutorial, I find that we are used to using a public image. So sometimes some people struggle to actually um, use a private a, deploy a private image and running it on in their container or in their pod. So in my own case, what I have an extra attribute which is called pull image secret. So this secret helps me to it use my authentication token to pull this image and provision the pod. So my container pod is 3000, right? So this is and I name it HTTP. So How to access this now? I can access it by the name, right? I can access it by name, which is HTTP. Then now I also have resources. So one of the benefit of setting up your resource limit is that let's say for instance now you have 1 gig, right? You have 1 gig, 1 gig memory, and if you didn't set up limit, your pod can actually consume so many resources uh, for no reason, and you find out that, oh, what I'm running, I don't even need much of this. So your this limit helps you to set up the minimum and maximum number of CPU and memory usage that can be consumed by each of the pod. Yeah. So if you have an edge check, so liveness and readiness, they have different purpose. So so what this one does, I think I heard it. The intelligence also describes it helps check the performance of a container if it is ready to receive traffic. This one is to check if your container is ahead. This one is to perform against container so that whether it's ready to receive traffic. Yeah, and this one determine if you can actually, or if it's actually ready to receive traffic. But this one is for pod. I mean, this one is for container. This one is just to check if you are ready to receive traffic. So and also this is an env, so there are different ways whereby you can actually map your env to your container. We have ev file, and we can also do this, which can you have value reference whereby you read from a reference. There are several strategies to this depending on your use case. However, any sensitive information should not be declared like this. The best way to do it is, or you can always read from a secret manager, like AWS secret manager, or Ashiko Vault. There are many secret management tools out there, so just check their documentation and map it to your container, yeah, or to your pod, yeah. So that is that on deployment manifest part. So we also have horizontal pod auto scale, right? Yeah. So this helps us to actually scale horizontally, right? So so we can have limit, at least we can have minimum of three pod running, right? And the maximum, we can't go beyond this limit that is set. And our CPU utilization. So once we started consuming on the host resources, once it's above 70%, we need to take care of our resources is working our pod. So are we adding more resource, or we are actually um, cleaning up some messes, or maybe for some reason the pod logs have grown beyond our expectation. So how are we reducing these memories? It depends on your strategy as a DevOps or Kubernetes engineer. Yeah. So ingress, like I said, so the benefit of ingress is that ingress helps you, it gives you, it make it easy for external users to actually call your services. So you're mapping this with your service. So our service here name is Node.js Node pod. So which is running on pod 3000. So rather than going through your IP address and the port, so users can actually access it through your domain name, which I have here, and this is a check. I added a README file for this, so which you can read more on this. So I tested this on ECS, so troubleshooting, because I actually set up Minikube, and yeah, so I have this README file that can guide you on how to install a Node.js, an Nginx ingress controller. Then you follow up the script. Ingress Nginx controller. Then if you want to access it from the aside wall, um this is the readme file. If you have any question concerning this, you can always hit me up and let me know. You can just drop on a quick call, and we'll resolve it. Yeah. Then a quick one I want to say, if you are using the memory limit for this is actually minimum of 4 gig RAM. However, you should be using 8 gig RAM because Minikube actually requires some um memory usage, a RAM usage, at least minimum of 4. Yeah. Was it 4 or 2? Yeah, minimum of 4 or 2 to run perfectly. And your disks, to just to be on the safe side, have 20 gig. Yeah. Then this is my secret. Then my load balancer. Um, okay. So we have type of, there are different ways whereby you can connect to your service. We have load balancer, we have cluster IP, we have node ports. So cluster IP actually communicates within so main pod connects to each other within that cluster. So this is how they connect within the cluster. So if an external users want to connect to that service, they can use the node port. And also most cloud provider work with our load balancer so that your traffic can be distributed easily. Yeah, so this is we have cluster IP, we have external name. I've not used this before, but I'm familiar with IP, cluster IP, node and load balancer. So you can read more about this. Yeah. And a better way to get familiar with this is the documentation. So documentation helps a lot in case of any update or any change. Just get familiar with it. Um, then this is our service, right? So our cluster IP helps several pod to connect to each other easily, but with their ports. Yeah. So to say less and go into practical. So let's go into this one after the other. Okay, I've spoken about this. Um, so now, so I want to run I want to run everything here. So our cluster is up and running. So Kubernetes kubectl apply. So I'm in the directory. Something that's not right here. An extension. What extension do I have? It's not correct. Okay, this is chat. All right. Okay, I'm not in Node.js. Right. Oh, I'm not. You see that. So, yeah, I have this. I've created this before. So, you here get all right. So let's check what we have. We have 3 pod running. Yeah. So like I said, if you are running our what's it called? Cloud provider helps you with their external IP helps you to manage you can use any of these cloud providers to actually manage how traffic is distributed to your pod. So this one is expecting a connection. Um, then the next, hold on, yeah, pod is running. Um, so this is our replica set. So currently now, um, we have three pod running. Like I said, deployment helps you to manage your replica set, and we have horizontal autoscaler. Our CPU using 70%, minimum of 3 pod and maximum. So this was created 3 days ago. However, can destroy this old one. Create a new one. Let's see if for any reason something is wrong with first file. So good. Get all. Let's see. Okay. So it's fast. It's up and running. So um how do we check this? We have to run port forward. We have to port forward our IP, our service. So before we get into that, um so running on 80, not 3000. My mouse trying to be funny. No, no. Um, okay. Okay, connected. Let me do this. So our health check here is crawl service HTTP. So this is good for troubleshooting on 3000. So let's see if we are connected. So we are connected. And if you check the backend, right, we have different endpoints. Let's check the readme for this. So these are the endpoints we have get users, posts, puts. So I've pushed this so we can test all these. Yeah, you can test all these endpoints. So once your pod is up and running and your service is you're connected to the service. So we're connected to cluster IP. Yeah, which is running open on port 80, right? Yeah. We can also connect to a node port. Yeah. So let me put on. So this is up and running. Just to clear my data, I hope my node container is not running. Okay, it's running on 3001. Okay, just to be sure, this one is running on 3000. So this is running on 3000. Okay, let me check. This is correct. Yeah, it's correct. All right. So Just want to be sure that nothing is going on. So we are good on this. Um, let me check what other. So I'll push this to GitHub, and now let me check the comment section in case we have any question, so that I can address that. So am I audible? Please thumbs up if I'm audible. All right.